All right, well, welcome everybody to the Morrison Planetarium. We'll be starting in just a little bit. All right, well, welcome everybody to the Morrison Planetarium. My name is Jackie, and I will be your pilot today. I'm up here behind you. Hi, everybody. That will be the last time I ask you to turn around. Now, as you may know, here in the Morrison Planetarium, we tend to have pre-rendered shows, more like a movie. But this one's going to be a little bit different. This is going to be completely live. In fact, we are using the software called OpenSpace. It's a NASA-funded software that you can actually download at home if you have a very powerful computer. Now, today's tour of the universe, we're going to start close to planet Earth, and then we are going to fly all the way out to the outer limits of our universe, our visible limits, and then we're going to come back home. I promise I won't leave you out in space today. But a couple of reminders while we are getting ready for our tour. While you're inside the Morrison Planetarium, we do ask that there's no food or drinks, so if you did happen to smuggle these things in, please keep them smuggled. And at this time, if you happen to have any electronics that produce light and sound, this would be a great opportunity to go ahead and turn them off, silence them, put them to stun, anything so that they don't pop out in the middle of the show. We are going to be in a very dark environment, and these can be very distracting to yourself as well as your neighbors. Also, a reminder, while you're inside the Morrison Planetarium, please keep your mask over your nose and mouth the entire time. Now, we do create a very immersive experience here in the Morrison Planetarium, and I have been certified as a pilot, but every once in a while we might fly off a little bit into space. But if you experience any motion sensitivities, such as dizziness, all you have to do is close your eyes, and your brain will remember it is safely here on planet Earth and not flying out into space. All right, and lastly, I am going to ask you to go ahead and stay seated throughout our show. If you do need to get up in the middle of the show, our exits are going to be at the top of the dome. All righty, well, I think we're about ready to start our tour, so go ahead and sit back, relax, and let's go ahead and start our tour of the universe. Okay, so we are going to start fairly close to home, a few hundred miles above the Earth's surface at the International Space Station. And the ISS is as far as humans travel nowadays. You can fit about 6 astronauts in this spot at any one time, and it is the largest object that we have built so far. And it's about the size of an American football field. Even if we think about it, it's the size of this building, the Academy of Sciences. But as we get further and further out from our planet today, we are going to see how far our human influence has gone. We're going to see how far humans have physically traveled, how far our spacecrafts have gone, and how far our human communications have gone as well. But for now, the ISS is as far as humans do physically travel nowadays, though there are plans in the works to change that. In the meantime, our astronauts are traveling very far around Earth. It takes them about 90 minutes to orbit us once, and in fact, you can see the ISS pass overhead in the night sky. Just look online to see exactly what time it's going to pass over your area, and when it does, look for something that looks pretty bright, like a star, but moving quickly across our night sky. Now, as I mentioned, we are using a software called OpenSpace. And the really cool thing about this software, other than you can download this at home for free, is that it is pulling data from satellites orbiting around our planet constantly. So we are actually seeing Earth as it was just about a couple hours ago. So this is exactly where some of those clouds were. Even sometimes we can see tropical storms. It's pretty neat. A great way to explore our planet and beyond. Okay, so let's continue our tour. And I'm going to go ahead and bring up some lines. And these are going to represent the orbits of some of the things in our solar system. And in fact, we are going to go ahead and travel to our closest natural neighbor, the moon. So let's go ahead and focus on our moon real quick and zoom on in. Now, the moon is as far as humans have traveled out into space so far. The Apollo astronauts were very lucky to be able to get out here in the 1960s, and it took them about 4 days to get to the moon. Now, even though the moon is our closest natural neighbor, it doesn't mean that it is close in human terms. The moon is about 250,000 miles from our planet. And as we get farther and farther out, it's not going to make sense for us to talk about distances in miles because we're going to be traveling very far. So instead, when we talk about large distances, I'm going to use a different type of measurement, so to speak, a different yardstick. I'm talking about the speed of light, the fastest thing that we know of. If we were traveling the speed of light, which is almost about 200,000 miles per second, it would take us 1.5 seconds to get to the moon. So we say that the moon is about 1.5 light seconds away from us. Now, I'm going to go ahead and zoom on in just for a little bit to take a closer look at its surface. Now, the moon gives the illusion that it's been hit by asteroids, comets, meteorites more often than us. But Earth is a much bigger target, and we actually get our fair share of impacts. But also remember, the moon has basically zero atmosphere, and so there's no weathering, no erosion, and there aren't any plate tectonics moving around. So nothing gets erased from the craters once they actually appear. Okay, so we're going to zoom on out just a little bit more and start to see the moon's orbit around our planet. Now, it takes the moon to travel around Earth about 29.5 days. And I like to call this about a month. But we'll go ahead and continue our journey further out, and we'll start to see some of the orbits of our other planets in our solar system. Now I'm going to go ahead and focus on the closest star to us for just a second, the sun. Now, if we were traveling the speed of light, it would take us about 8.5 minutes to get from to the sun from the Earth. So it's about 8.5 light minutes away from us. And we start to see some of the inner planets. We have Mercury, Venus, Earth, Mars, those rocky inner planets. And farther out we go, we start to see Jupiter, Saturn, our gas giants, and then Uranus and Neptune, our icy giants. But as we come on out, I want to pause for just a moment because there's something in our solar system that doesn't get talked about very often. It's a little less known object, kind of in this area that's seems like there's nothing there, where usually our asteroid belt is, and it is there. We just can't see it right now. Does anybody happen to know what that object is? Go ahead and shout it out if you have an idea. I hear Pluto, maybe Ceres. Well, it actually is Ceres. And I brought up its orbit now. Now, the reason I like to pause here for a moment is because Ceres is a pretty cool object. It's called a dwarf planet. And I'm pretty sure you all know about another dwarf planet in our solar system. Go ahead, shout it out. Pluto, exactly. So Ceres and Pluto actually have a very similar story. Now, when we first found Ceres around 300 years ago, we thought it was the only thing orbiting in between Mars and Jupiter. But around that time, we started finding more objects. They were small and rocky objects, and we started calling them asteroids. In fact, I can bring up that asteroid belt now. So we changed Ceres' title from planet to asteroid. Similarly, this is what happened when we first found Pluto. We thought it was the only object out here. And I've brought up Pluto's orbit as well in that kind of light bluish color. But in the late 1990s and early 2000s, astronomers started to find all these other objects, mostly small icy objects, but some of them were about the size of Pluto, and at least one, Aries, is bigger than Pluto. So instead of adding a bunch of new planets, astronomers got together and said, maybe we should come up with a better category for some of these small objects. To have an idea of what's out here, I'm going to bring up what we call the trans-Neptunian objects. Now, not all of these are big like Pluto. Most of them are smaller, those icy objects. But those astronomers got together and decided, okay, we need to define what a planet is. And they came up with 3 requirements for a planet. 1, it needs to orbit a star. Well, Ceres and Pluto, check. 2, it needs to be large enough, massive enough to have its own self-gravity strong enough to pull itself into a round spherical shape. Well, Ceres and Pluto are spherical, check. Number 3, it needs to have cleared its path, meaning it needs a relatively clear orbit. Well, as you can see, both Pluto and Ceres do not have a clear path. So this is why we now call them both dwarf planets. Okay, so I'm going to go ahead and turn off some of these bigger things. And as we come on out, I want us to go ahead and take a moment and check in about how far we have gone. Now, if we were really out here in Pluto's orbit, it would take us about 10 light hours to travel. So we say that from one side of Pluto's orbit to the other, it's about 10 light hours across. Well, remember, it also took us about 8.5 light minutes to go to the sun from Earth, and it takes about 1.5 light seconds to go to the moon at the speed of light. But let's go ahead and check in on our human influence. We've seen how far humans have gone. Let's see how far our spacecrafts have gone. I'm going to start to bring up some orangish lines that will show how far our fastest and farthest spacecrafts have gone so far. We are now seeing Voyager 1, Voyager 2, Pioneer 10, and Pioneer 11 that were sent out in the 1970s. And more recently, the New Horizons spacecraft went out to Pluto back in 2015. Now, these are our fastest and farthest spacecrafts, but they haven't even gone as far as light travels in one day. Okay, so let's continue our journey. We have quite a bit to go. And now we are actually going to start to travel out here in distances of light years. And we'll start to pass some of the other stars in our galaxies. And the closest star to us beyond the sun is about 4 light years away from us. So it would take us 4 years to get there if we were traveling the speed of light. Okay, so I'm going to pause here for a moment and check in one last time on our human influence. And yes, that might seem a little funny that we have influence way out here, but I'm going to bring up what we call the radiosphere. And this sphere is how far our first television signals and radio signals went out. Now, so far they've gotten out into space, and a reminder, the earliest radio signals were sent out about the 1930s, or at least the ones strong enough to escape our planet. So this is about 90 light years away from us in all directions. Now, since all our radio signals are traveling at the speed of light, we can actually measure this distance, which is kind of neat. Okay, so we have this radiosphere. How many planets are out there? Well, we've been searching for quite a bit of time, and we found thousands of them. In fact, every ring you see now is around a star that has at least one planet orbiting it, what we call an exoplanet. And if we look really carefully, we can see that there are several planets inside that radiosphere. So who knows? Maybe there's something or someone out there listening to I Love Lucy or Nat King Cole right now. That'd be pretty cool. Okay, well, we got to continue our journey. And because we are flying past the stars in our galaxies, we haven't even gone outside the Milky Way yet. Now, as we zoom on out, I encourage you to keep an eye on the radiosphere to see how long you can spot it. And soon we'll start to see the large-scale structure of our galaxy. Let's go ahead and look at it a little bit closer. Now, we live in a spiral galaxy. So it's pretty flat disk, and it has several spiral arms of gas and dust and stars. And in one of those spiral arms, about 2/3 out from the center, you can see us. And right at the center of our galaxy, we can see a big group of stars, very, very bright. And if we could see past those stars right at the very center of our galaxy, you would see, well, actually basically nothing, because there is a supermassive black hole at the center of our galaxy, and it doesn't allow us to see any light. It's about 4 million times the mass of our sun, which is quite big. All right. Can anybody still see that radiosphere? Go ahead and try to point it out. Right about there. So that's our little neighborhood, our corner of the galaxy. And that is as far as human communication has gone so far. So we are now up to a distance of thousands of light years. Now, from one side of the disk of our galaxy to the other, it's about 100,000 light years across. So if we could take a trip from one side of the galaxy to the other, it would take us about 200,000 years. Okay, but our galaxy is has roughly about 400 billion stars, but it's just one galaxy out here in the universe. Now, every single dot we see is not a star anymore, but another galaxy with its own billions and sometimes even trillions of stars. And the colors of these galaxies may look like it seems like somebody accidentally spilled some cosmic Skittles in the universe, but these are not the actual colors of the galaxies. It shows us the different surveys that have mapped our galaxies. Okay, so we are now going to zoom out far enough to start seeing that structure of our universe. And when we zoom out this far, we start seeing something a little bit funny. We see galaxies grouped together, but at the right angle, we start to see some strange things. One, it makes it look like we are the center of everything. Well, I hate to tell you, we are not, although many people think they are. This is because of our perspective. We are looking and mapping our galaxies around us from looking out. So it makes it look a little strange. Now, if we would go to any other galaxy in our universe and we were looking out, it would actually look like we are the center as well, and everything was moving away from us. All right, the other thing that makes it a little strange is that we see these big gaps. And it makes it look like our universe is the shape of a bow tie or butterfly. Now, as cool as it would be to have our universe the shape of a bow tie or butterfly, it actually isn't. This happens because of our own galaxy. Remember I told you our galaxy has a lot of stuff in it, gas, dust, stars in it, and these things block our view. So we can't see past our own galaxy. So we believe that there are definitely more galaxies in all of these directions. We just haven't seen them, so we're not going to map them. Okay, so we are going to continue our journey. We still have a little bit more to go. And we are going to start to see some of the earliest objects in our galaxy, or in our universe, sorry. These are what we call quasars, the bright cores of some of the first galaxies. And I do say earliest because anytime we are looking at anything out into space, we're kind of time traveling in a way, because the light from these objects has to travel so far that by the time it travels all those distances and gets into our telescopes, we're seeing the light as the objects were in the past, not how they are looking today. So, for example, we were looking at the closest stars to us, about 4 light years away. That's how it looked 4 years ago, not how it is today. Now, we're seeing the universe as it was about billions of years ago. And because of that, that means there's only so far we can go. There's an edge to everything we can see in the universe. And that edge is now all around us. This is what we call the cosmic microwave background, or the CMB. Now, if you had a radio telescope that could see in the microwave range of light, you would see this everywhere you looked in the sky. In fact, the first radio astronomers were pretty confused by this. They looked up into the sky with their telescopes and they were like, what is going on? Why am I seeing interference everywhere I look? But soon they realized that it was something out into space that they were seeing. Now, this is a few 100,000 years after the Big Bang would have happened. So we can actually think of this as kind of like the baby picture of our universe, the first light that we could see. But since this is the baby picture, and this is as far as we can go, this also is the end of our journey. So we're going to go ahead and head on back home. Now, if we were actually that far out into space and we were actually flying the speed of light, it would take us about 13.7 billion years. But thankfully, we are in a planetarium, so it should only take us about a minute or so. Now, one more thing I want to point out as we zoom on back home is all of this that we have looked at today. All these stars and galaxies and the cosmic microwave background, that's not everything that's in our universe. There's dark energy, some mysterious force that's causing space itself to accelerate as it expands. There's dark matter, some mysterious substance that doesn't seem to interact with light at all, but we see evidence of it in between and the edge of galaxies especially. And we call all of these things dark energy and dark matter because we're not quite sure what they are yet. But we do know that they make up about 96% of our universe. So everything we have seen so far, that's only 4% of everything that is out here. And that may make us feel small, that we're this one tiny dot in this homogeneous universe, but I like to think of it this way. Well, yes, we are this one little dot, but look at all that we have found. We have found so much so far, almost entirely by looking through telescopes. All right, so we're going to zoom a little bit faster. And as we come up to our galaxy, we're going to start to see that human influence one more time. We're back in that radiosphere, our technology signal. And this is our little corner. Now, as we come on into our home, I want to reflect one more thing, that we are in a wonderful time in human history. We're able to not just learn about these things, but we're able to show them like this, to map the cosmos in 3 dimensions. And that's pretty cool. And we're starting to unravel the true nature of our universe, but we're only just starting. The rest, well, that's up to the next generation of scientists back here on planet Earth. All right, everybody. Well, we are back home at the 3rd planet from the sun, the only place in all of this that we have found life so far, which is also pretty incredible to think about too. So, welcome back, everybody. Hooray!